All right, welcome everyone to the HEIR meeting. Asra, why don't you take it off with the notes from the last month?
All right, I guess last month we had 71 PRs, which is like quite a bit from the month before that. So there was a bunch of build fixes, nothing too notable for other people, except that there's been a lot of progress on Python packaging. That's the fourth bullet point. So I think it's almost done. I think Alex had like another CL this morning. And so hopefully, fingers crossed, I think minus macOS, right? So that one might be disabled now. And then, yeah, other than that,
macOS works, but if you have an Intel processor, it doesn't work. And the macOS one that works doesn't support OpenMP.
Yep. We can send you a package, but we can't get it to build the Intel macOS one on CI. So it works locally, but if you have an Intel Mac, I'm sorry, you're going to have to build from source.
I see. Okay. And then we also fixed tracking the nightly releases. So I think hopefully we should have a better tracking handle on like the HEIR opt and HEIR tools binary or HEIR translate binary tools that are uploaded on the nightly releases. All right. And then there was some work from Chronami side. They added their systolic array backend. There's 2 PRs from that side. And then I think we talked last time, one of like the pillars that we're working on is performance. And so one contributor added extended basis rotation for OpenFHE. So that does the like fast rotation pre-computing so that you can defer key switching and do some processing in the extended basis. And then as well, on the compilation side, we also split out the pre-processing utils to a separate file that can be compiled as a separate unit. So in Latigo now, if you enable pre-processing, then it will build all the pre-processing as a separate util target, and then depend on that for the main workload. In theory, that was supposed to help some compilation, but the problem is that pre-processing is actually like 90% of the size of the entire workload. So now that it just means that pre-processing util target is slow to compile. So we still need a loop support in there at least, which should actually be somewhat more trivial because it's just plain text processing. Okay, and then that brings me to the other pillar that we talked about last time, which is the massive part of loop rolling. So I think I covered all the PRs that were related to loop rolling in this big chunk, although some of them are like more fallout things than they are like directly related, but most of them were related to supporting dynamic indices in the rotation, because if you have a loop now, you don't have static indices for the rotation. And there was also a bunch of fallout from the if statements that might have to be like condition. I guess one branch might be plain text returning, one branch might be ciphertext returning. So there was a bunch of handling to reconcile that type conversion. Anything else notable? So I guess the notable thing here is somewhere in the middle, there's this pass implementing trivial encryption as a CTPT add. So I guess that's a notable change to make if you're curious about how this might be working, but we don't currently have a backend config that can tell you whether a backend supports a trivial encryption. So right now there's a pass transform that Jeremy added, or rewrite that Jeremy added, that will take a trivial encryption at the LWE level and then rewrite that as a addition of 0 to addition to a ciphertext encrypting 0, so that you can return a 0 trivial encryption. And so that 0 encryption is handled by the client. So the client will also send a 0 encryption over, and that's added as a function argument and annotated as a 0 encryption, and has a client helper to help create that. So we kind of discussed this at length of like, should we just always do that? Should we leave that to, deferring to? So I think when we have a backend config, we can more effectively decide when to apply that rewrite, or otherwise keep that LWE trivial encrypt and have a lowering down to the trivial encrypt the backend exposes. And anything else other notable wise? So I talked about the rotation.
I think the update there is after all of the there's still like 1 or 2 in progress PRs, but once those are in, then you'll be able to lower. I think the code gen is still not. The code gen is working, but the code that's generated is not fully compatible with Latigo yet. So like, I think some of the primes that are being generated don't have the right divisibility or something like that. So there's a couple of bugs left, but it's like very close to being done with fully rolled like MatVec kernel. So that's like probably in the next week or two will be done.
Which should be awesome because I think the MatVec kernel will expose anything relying on a MatVec, including the convolution. So
yeah, and it compiles in like a second now, so it's like very fast to compile.
Yay! Yeah, that will be awesome. I also added a small section of just like cleanup and det stuff, including some like non-functional changes in here. We renamed the HEIR SIMD vectorizing passes from Alex's paper and a while ago when we started this project to HEICO SIMD. And there was, I guess the other notable thing here is the Latigo pipeline is now aware of what rotation keys are required to generate for a linear transformation op. So thanks, Alex, for adding that. Before we didn't have support for that, and so you just kind of had to manually write that yourself. So now Alex ported over the logic of like which rotation keys would be needed in order to do that linear transform. So fingers crossed that works. If it doesn't work, then blame AI.
It
And
works.
then-
We're using that already in our tool. That's actually why I integrated this into here, because I realized that if we don't do this, we have to generate a bunch of like ugly helper code every time. And so, yeah, definitely the more we actually start using HEIR, the more I like find these little like convenience things that don't matter if you're building tests, but do matter if you're building tools.
Yeah, and I think the context behind that as well is that Alex has been working on benchmarking and utilizing some of the HEIR pipeline. So going from Orion to HEIR, and then that's where all this is falling out from. I don't think anything else in this particular section is particularly worth noting for users. So I'll go on to say like new passes. So Edward has been adding porting over some work that he's been doing and his group has been doing. So the ILP bootstrapping placement passes there, and an example of a ROTM layout MNIST is also in there now. So you can see the code generated from what ROTM decides to assign layouts for. And yeah, that test is committed in there. And then also, I think, is this Vedant's work, the graph? I think it is.
Yeah, so I think it's the two pieces of context here is for Edward's work, their goal is to get ROTM, and the ILP thing is from a paper called Orbit. And then they also want to get Cerium, which is their GPU backend, all into HEIR so they can do like fully end-to-end performance benchmarking, and then like add additional optimizations on top of that. The second two are from, there's the group that did Coyote. I forget the university, was it
Purdue?
Purdue, yes. So they want to make some extensions to it, and they decided to do it on top of MLIR. So they have written, I mean, it's sort of ongoing research, but they've written sort of like a compatibility layer between HEIR and Coyote tooling. And then part of that, because they do like a procedural analysis. And so part of that is like understanding the function calls and what the graph of procedure calls looks like. So they had to do a bunch of graph util stuff, and they upstreamed some of that. But most of their code is still not public.
All right, yeah, I guess I mentioned now the three papers, Orbit, ROTM, and Coyote. So you can go look up those papers. And then a couple of docs, I guess notably, Alex and I were at Real World Crypto and FHE.org 2 weeks ago or so. So there's a commit to the docs on the poster that was presented. Alex ported that over to HTML. So you should be able to like nicely see that online. And we added a little bit more about the AI tools policy. And then we also added some instructions, the basic instructions for how to convert Torch models with Torch MLAR to work with the Torch Linalchasica KS pipeline. And then also I will expect, Jeremy's at Asphalt right now, so I'll expect some more docs on his slides over there and tutorial slides, I guess. So we'll also see that on docs.
Yeah, those were recorded. So I think once I get the video from Jen Ming, we'll put them up on our YouTube channel.
Yay. That'd be awesome. Some more tutorial, more up-to-date things. And then the other pillar that we mentioned too on this convolution support, so I'll give a quick update on how that's going. So this is implementing multi-channel 2D convolutions in the way that Orion also has their layouts. So what this one does is it converts a multi-channel convolution into a big toplets matrix. And then, so that support for creating that layout is already done. If you want to create multiple inputs and outputs as well, then you will have to like extend that matrix to cover the multiple inputs and multiple inputs and multiple outputs for extending the rows and the columns. And then the other part of that is that average pooling will also convert to this multi-channel convolution with like a constant kernel matrix. But an average pooling will downsample. So it'll have some striding. And so in order to do that more efficiently, Orion has a row permutation or like a row interchange permutation that will move around the rows and also then convert the output layout. So it'll shuffle around the outputs in order to minimize the number of non-zero diagonals in the matrix. So support for that, I think, is in that last PR. And so we have some testing on calculating those number of non-zero diagonals as well. And so the update there is that I'm just plumbing those layouts through our system now. So I'm at the step of actually materializing the kernels, and that's where I'm at right now. And so hopefully once that is done, it will be done and we will have 2D convolution support, and I'll start to re-enable some of the testing for average pooling and for the CNN models. Yeah, so fingers crossed that next week that will be done. And then also, I guess as a small update too, Eric had been working on this like NTT and polylevel. I
can talk about that. So we got the relinearized implementation done. It's lowering down to polynomial. And then on top of that, Eric went and added like an optimal NTT placement algorithm. So it's like actually like a proper solver that it is a CP SAT solver to decide where to insert NTT and INTTs. In addition to like adding the, like, it's like he did some other refactoring, like making polynomial have the what form it's in as an attribute on the polynomial type instead of having NTT go back and forth between tensor types and polynomial types. So now it's all in polynomial types, and then that attribute is what is being set by the solver output along with inserting NTTs. And then I think now he's at the point where he's lowering individual, like an NTT of a RNS polynomial down to NTTs of individual limbs, or there's a limb-wise expansion that he's doing, and then he needs the to populate the what's it called, the primitive root on the NTT, which we added the code to generate the primitive root, but it needs to be populated. And then I think he's going to have an end-to-end all the way down to LLVM of relinearize, which is going to be a big step. So that's, I think, in progress, but that's the context that's been happening here.
All right, and I think that's all the new updates. The in progress things as well are mostly along the lines of that. So nothing to say there. We have the same sort of like progress on the pillars from Coyote, from the convolution, from Jeremy's loop unroll. And then I guess the small update, Alex, you just posted this PR too about supporting linear trans ops as a wholesale thing for Orion in the OpenFHE backend.
Yeah, I think basically all of the PRs you're going to see coming out of me in the next weeks is going to be either packaging things to make things easier to use, or it's going to be making the machine learning pipeline target different backends, right? So the existing work was on making the Latigo backend a bit nicer to use, and now this is doing the same thing and also adding a bit of the missing things. FHE doesn't quite have the same API as Latigo. And so hopefully this will also then soon be followed up by a FIDEslib thing, which will have a similar thing. And I think there's one PR in progress also, which is to abstract away the analysis, extending the rotation op interface, right? Because the original Latigo linear transform was just hackily looking at what the rotations are, and Jeremy had some really nice ideas for how to make that not hacky. And so, hopefully I think what I'm trying to do is make HEIR less brittle with regard to backend stuff, so that you can like take any CKKS thing and lower it to any of the backends. I think that's kind of the goal that we have at the moment, right? Because obviously we primarily care about eventually hitting the really good like step to go Latigo, OpenFHE, Fightlibs, HEIR, right? Like sort of with each step, you expose new assumptions in the compiler.
Yeah, I think one of the biggest assumptions that confounded me, because I was originally trying to do this with going from Orion to CKKS down to the different backends, and the big issue with Orion was that its scaling placement was specific to the like scaling aware linear transformation operation in Latigo in a way that I could not easily replicate in OpenFHE. So once I got something lowering to OpenFHE, what happened was it would run out of levels in the middle of the linear transformation op in OpenFHE.
Yes,
and
so
I would need to.
the solution here is pretty hacky. It's basically we're emitting code that does the Latigo style linear transform against the OpenFHE API. So like basically, includes a bunch of like a long template thing that we emit along with our code. That's basically like, you know, hey, here's the lintrans that we want, rather than the one that OpenFHE gives you. So it's essentially porting the Latigo style linear transform.
And well, the other thing was like, I was like, okay, well, maybe I should just implement the linear transformation thing that Latigo is doing in HEIR directly, right? Because I also tried lowering the linear trans op to our normal kernel and then lowering that to OpenFHE backend. And that had the same problem, that it needed extra bootstraps in the middle of some operation. It got like almost all the way to the end of the lin trans op, and it was like, oh, I ran out of levels, and it was like 2 ops later was the bootstrap. So yeah, I ran to this.
I don't think we're going to get around this entirely. I feel like
the reason I couldn't do the implementation of lintrans in the Latigo style boiled down to the fact that our code base does not support high precision scale management, because it just supports like how many bits are there in the scale. So if we supported high precision scale management, then we'd be able to port the Latigo style like into our own direct kernel. So that, I mean, just for context, that was where I got stuck.
Yeah, no, I think
I don't have time for
very
this.
much. There's a reason there's a work in progress here. This is very hacky at the moment, and I think I think what we probably planning to do is also make Orion more aware of the different backends a bit. But I'm sort of hesitant to put too much effort into Orion, because we know obviously that long term we want to just do PyTorch to HEIR, right?
Right.
So, but yeah, I think there is a problem to make Orion just be blissfully unaware of the backends, because there will be different amounts of bootstraps in some of them. But at least for some of the simpler models, this is good enough to make it work. But I think the other thing is maybe we do the like nicer high precision rescale thing in HEIR, right?
Yeah, I mean that will take a while, right? But that was, I mean, just wanted to give everyone context that like we had gone through this, and the scaling was really the thing that was the assumption between the 2 different backends that differed. Okay.
All right. Notable new issues. I did want to call out, if anyone has OpenFHE experience too, we filed just a follow-up issue to explore sparse packing properly. So I guess this is like, you know, if you have like, let's say you're only utilizing 1024 slots, that you would embed that 1024 slots into that larger ring, so that you could save out costs on bootstrapping, or mostly bootstrapping, and then I guess technically like encode and decode. But yes, if anyone wants to add that, I don't think that that's too difficult to do. It's not too invasive either. And then some other things I wanted to call out. Right, we did file an issue about the FHEbenchmarking.org code gen. So FHE benchmarking is an effort to like have some standard FHE benchmarks. And there is some boilerplate around creating the server preprocessing and main workload and client preprocessing and or client encrypt and decrypt workloads. And so there's a bit more code gen involved. Although we have some of the pieces already there, we need to like package and configure them in a way that FHE benchmarking expects. So creating separate files for each of those processes, and then making sure everything works with that. So that's also up for grabs, really. And so that's kind of a broader effort. I think all of us would like to see, you know, just an easy way to port over benchmarks. Would save a lot of effort.
Yeah, the MNIST benchmark from this one was generated by HEIR, and then a bunch of boilerplate was added around it. So it's like MNIST running on OpenFHE, I think was that benchmark. So it's been done through HEIR, and I think if we added some extra code gen, then it would make it a lot easier to do more.
Yeah, I think that that's about it, besides things that we already are on the same threads of what we've been talking about.
Topics for discussion. I have been reaching out to people over email, but there's this form, and we're asking about people who are contributing or trying to use HEIR and what are the pain points. I think especially for new contributors or new users who are trying to get oriented in the project, I think it'd help if you provide some feedback. And then we're gonna, in the next like month or so, we're gonna be doing like a documentation sprint where we're gonna go and like redo a lot, like improve a lot of the docs to make it easier and like put some effort into like cleaning up some of the front ends and stuff like that. So yeah, if you have a chance, and you can also, if you want to just say the feedback now, you can do that now, and then we'll write it down. You can do it offline. You can DM me or send me an email, and then I'll incorporate that into our notes. So I will pause for a moment to see if anyone has any feedback that they want to share right now. Okay, all right. We can move on
Mostly it's Mark.
yeah. We can move on to the next.
No,
topic.
but I'll write up. I mean, I'll gather my impressions and I'll do that offline. I'll fill up the form.
Yeah, that'd be helpful. And then, okay, so updates from conferences. I don't know if anyone has anything particularly interesting to share. One thing I can start with ASPLOS because I think there's not too much, but the topic of ASPLOS in terms of FHE is definitely GPUs, GPUs, GPUs. I was surprised there was only one person I saw here that was working on ASICs. And yeah, Cheddar is the last talk today, actually. The very last talk of the conference is Cheddar. So I will be going to meet the authors and talk through some of the details. But everyone is talking about GPUs, and I think Craig Gentry's keynote for our tutorial was like, do we need ASICs at all? Can we just do everything in GPUs? And his big reasoning was like, the algorithms are changing fast enough that the assumptions that you're baking into the ASICs are not going to hold by the time the ASIC is ready. And some of the things he brought up were, okay, his matrix multiplication kernel was like the big one he brought up. And then the other ones were like people doing work on different ring structures that have different assumptions about entities. Some folks apparently are doing some work with out doing RNS anymore, and they're just doing high precision integer math and doing it somehow fast on the GPUs. I had the paper written down for that one, but I have to look into it. And then, sorry, what was the other one? And like some people are doing stuff with like multivariate rings as well. And so he's like, okay, if all this stuff is changing so fast, like probably it's not the time to do hard coding things into ASICs yet. And it seemed like everyone in the room agreed, and they also all worked on GPUs. So yeah, anyway. Any notes from HES or FHE.org? I don't know, did anyone go to HES in this room? I don't think so. No, okay.
No, I did hear Dave Archer was there. I think there was a couple other people there as well. And Florent was there. So next time I meet with Florent, I'll also get some updates from him. At FHE.org, there was some like related interesting work from the BGB noise analysis side, and they were interested also in integrating some of that noise analysis experimental validation using HEIR. There was also lots of talk and interest about LLMs, I think, people doing compilation for Llama, people utilizing Heon and different things like that. So there was a couple of things that we don't work on, I guess, in HEIR yet, and we don't have support for things like grafting or things like on the larger transformer infrastructure side. So that's something that I think is still open, and we would love, I think, for community people to reach out to us if they're working on that and see where we can help with that and benchmark some things a little bit. So there was a lot of interest on that.
Does anybody here know what grafting is?
I think Alex does, maybe.
No, just that it's one of the magic advanced rescaling things, right? I haven't looked at it enough. I think also, I think also honestly, it would be very helpful. Maybe this is a research synthesis issue that we should create, which is to actually like sift through all the advanced rescale things and figure out which of these are even unique ideas. Because I think this is very similar to the packing thing, where there is significant overlap between different ideas, and the notation might be as much of a difference as the actual like underlying insight, right? And so I can't help but feel that there is significant overlap between a lot of these like advanced rescaling ideas.
Was there a paper for grafting? I don't know if we could
Yeah,
post that
pretty
as
sure.
an issue. I hadn't seen one.
Yes, I'm trying to find it, but there's a ckks.org. They have a blog and they talk about grafting and they reference the
And it
paper.
links, yeah, it links the paper. Let me link it here. I guess I can just put it in the doc. That's probably easier. Where is it? Yeah, but there is a paper for grafting, and I think it will be interesting to understand all of these different things. I'll link the blog because that then links to the paper as well. But the paper is literally called grafting.
Oh, that's right. Johannes went to crypto
Yeah,
lab.
this is one of the mono things.
Okay.
Yeah, so I think this is maybe something that's yeah, would be very interesting also to discuss with like maybe Ed and like the folks that have been staring at like solving the like rescaling optimization problems and how techniques sort of impact the optimization problems that we need to solve, right? Because I have a feeling they definitely open up the design space quite a bit, but that doesn't necessarily have to mean that the optimization problem becomes a lot harder, right? So yeah, I think having support for them kind of technically isn't a problem with HEIR, right? In some sense, it's the fact that like we don't have support for them, yes, but like the reason is because none of the backends we have support any of these techniques, as far as I know, right? So this might also be something that only really becomes viable if either one of the major libraries starts adding it, or if our LLVM backend becomes mature enough that we can actually start implementing things into it, rather than having to wait on. Yeah, I mean, here I'm great, but like that's not one of the backends we are primarily focused on, right? And it's closed source. I think having either a good open source backend implemented or having our LLVM backend be mature enough is sort of a precondition. But yeah, I think research synthesis already makes sense, even if we can't implement it in the short term. And I think the same thing goes, I don't know if we already have an issue for this for all the advanced matrix multiplication techniques floating out around there, right? Gentry Lee, etc.
There's two. I mean, there's the coefficient domain one and the slot domain one.
Yep.
Yep. I think both of them are open for implementation in HEIR. I don't think that it's completely decided which one was better. Just because the slot domain one has like more, like it doesn't have more key material. There's like some memory issues.
Some of the differences between them is that the Park one, because it works in the coefficient domain, you will have to do a coef to slot transform if you want to do some multiplications. And then the size of the matrix is also limited. So you can't really easily split it a larger matrix size over the number of coefficients that you have. And then in the Gentry Lee scheme, I guess the limitation or downside is that you have a pretty heavy lift of a key switching operation to do. So that since the ring is like now multivariate, you have to sort of do a little bit more, like the key switching domain is a little bit larger, so that the space of your key is larger. But it's no larger than like 3 or 4x the normal key switching, and it's still, I think, maybe less than a multiplication in like CKCast style multiplication. So I think those are the kind of limitations there. Although, yeah, so the lack of the coef to slot style transforms was interesting. You could do everything still in the domain of the Gentry Lee scheme.
Okay.
Yeah. But again, same, right? We either need a good open source backend or a stable enough that it makes sense to actually implement it in here.
Yeah, I mean, we're looking at where we could implement it ourselves. I don't know if there's any limit on what we can say out loud, Oscar, but we're hoping if nothing else happens, then we will be providing the open source implementation for our own purposes. So TBD.
Okay. So maybe a point not necessarily related to the conferences, but to things that were popping up. In fact, I was kind of hoping to discuss it today because Eric has been very consistent about showing up to these, but unfortunately, I guess I picked the one where he didn't. But now that Eric is hitting the lower end of the pipeline, like actually lowering all the way to mod Aerith, I think it would be great to have a bit of a discussion about the state of mod Aerith, driven by my collaboration with the Cambridge University folks and the verification effort, which is sort of currently stalled both on me getting better at lean, but more importantly, is a bit stalled on the fact that like you can't actually show anything useful about mod Aerith in here at the moment because it's not like semantically, logically consistent at the moment, right? We sort of don't have a super clear, like we use it both to represent the abstract concept of ZQ operations and the implementation of these things in like things, Barrett reductions, etc. And so I think we already discussed that the solution to this is probably just putting an attribute on there, or like maybe using different sizes and like different types. But I think because Eric is the only one that's really sort of targeting that lower level dialects right now, I don't want to go in there and start messing about without at least having a like discussion with him about what his plans and needs are, because I think whatever we can whatever we can do to make it easy for him to work with it should have priority, making it nice to verify.
Well, we had talked about we had talked about upstreaming Modarith, right? Well, you were involved in these most recent discussions, right?
Yeah. So I think the point is sort of like especially if we do want to upstream it, we probably want to get the like design right before we do it. And so I think maybe we also need to get some of the LLZK folks involved if they are
we did, right? So I have a doc and I have to find it, but I wrote a doc where it was like going through both our project and all of the ZK type project and trying to figure out like, okay, where are the actual passes that they're using and then trying to figure out like a version of this that could live upstream long term and meet everyone's needs.
I think for them it's a bit easier because they usually just use it to mean operation, like abstract operations in ZQ, right? Like that's for the most part they have pre-existing library implementations that then handle the actual like implementation of that. So they don't. I think none of them use their like felt or whatever like types to also represent the like nitty-gritty implementation of modular arithmetic. And so I think maybe we just do that, right? Maybe we also
some of them actually do Barrett reduction, but it's all happening in a lowering from side of Modarith. So like they get rid of Modarith by the time they're doing the reduction implementation. And so if we
maybe
want
the answer
it as passes like inside Modarith. But my big concern was like it was unclear, like because there's 7-8 different modular reduction techniques, and you can kind of interpolate between them in different ways, and it was unclear to me like how much effort to put into doing any of these. Like we don't expect LLVM to be the primary backend for FHE either, right?
Exactly.
So like why would we bother spending all this time doing like things to target LLVM? If we're using it more just for correctness testing. So then like which of the backends would be focusing on like mod arith in a way that needs intelligent reductions as like a compiler pass? And the only one I can think of is Jacksite on TPU, because that's like its main contribution is a special reduction method that works for TPU.
I guess also there might be some interest, and I don't know, this is just a hypothesis, it might be interesting for if you want to actually do like kernel fusion based GPU backends, right? Like where we're not just library. But it might also just be that like it's such like that it ends up being trivial, right? That there isn't a lot to compile around this, where it's just, we do this modular arithmetic thing and here's a template kernel that we provide, and you just and then so it's currently not entirely clear how much compiler infrastructure we need to build around mod Aerith. But I think what would be nice if to maybe what we do for now is just we determine that no, mod Aerith is magic abstract ZQ math, and then we have like mod Aerith X for our own internal use at the moment that we don't upstream, that has like all the Barrett reduction and ugly things in it, right? Something like that. But then we're also like not sharing the hard parts with the community. I think that's really the so that conversation with Eric to understand like exactly what we need, and maybe to rekindle that conversation with the others, because I think unfortunately the RFC has sort of lost a bit of steam.
Well, Well,
that
yeah,
would be,
I was thinking that I would need to like actually implement a prototype PR against upstream
Yeah.
in order to like get it to the point where people can actually look at it and say, yeah, this is what we want. And I had trouble getting like clear answers from the LZK people about what they actually needed out of this dialect. So yeah, I'm reluctant to start upstreaming this until we are
Yeah.
at a point that it's not going to become abandonware.
yeah, exactly. So I
Like
think
the
like,
polynomial dialect did.
I was gonna say it's much easier to work on this, I think, with everybody, and then once we have a consensus, like propose an RSC for that, rather than just sort of upstream something and hope they use it.
Exactly.
But yeah, so I think this is just a reminder of, I mean, Eric, hey, if you're watching this, otherwise I'll also reach out afterwards. Let's maybe set up a meeting at some point and figure out what we actually want, like what our ideal mod Aerith looks like for us internally. And once we know that, we can reapproach the other folks and be like, hey, does this match your vision?
Mm-hmm. And I feel like the answer for us is that we just need it for the type system, really, right? And we just need all of our passes to work, right? As you said, like over Magic, mod Aerith, and then defer to the back end that supports these things natively in some sense.
Well, I think at least for the LLVM and maybe for the like GPU kernel fusion thing, it would be very nice to have the actual, like to not just have it all be in lowerings like the LLZK folks do it. But for example, I'm kind of thinking there's probably an ILP somewhere in there where you decide where to actually do the reductions, right? Or something like that. Or because I think this feels very similar to a lot of the problems we have in higher levels of the compiler, right? Where you're accumulating stuff until it becomes too large and then it will overflow, right? Like this sounds exactly like the realization problem essentially, right? And so I wonder if we don't want to have an explicit representation so that we can optimize the reduction placement. But that sort of implies that there is to be done, right? Maybe it just turns out to be trivial. But yeah, so I think those are kind of I think that's kind of the things like to think about, is there even enough performance to be gained here, right? Because we're already at a very, very low level kind of like tweaking thing. And it might just turn out that, like saving one relin is like as good as optimizing a million reductions away or something, right? And then like, where do we put our effort? Yeah. But I think for my end, what I will try and do is talk to some of the GPU folks at Belfort and figure out if we sort of have like drive from that side to figure out how. But basically, this point boils down to let's revive the mod Aerith discussion both internally at HEIR and also with the other folks.
Yeah, I do feel like it's a little bit of diminishing returns on that side of the house, based on like what we need to do now. But yeah, I'm still open to. I mean, I probably won't personally have the time to do a lot of this consensus building. So
I mean, I think my point is sort of like, if I'm going to be spending like a third of my time this year verifying the mod Aerith dialect in Lean, I want that to like be the mod Aerith dialect that still exists at the end of the year, right? Because we're optimistic about how updatable all of these proofs will be, but like I don't want to test that first thing, right?
Yeah. Okay. I have this doc that's not public yet, so I can't show it publicly at the moment. Okay. So I can't post the link in here. But if you want to be involved in this discussion, reach out to me and I'll share the document with you. For anyone,
really good. Yeah. Oh yeah, and maybe on the note of formal verification, really briefly, this is technically an update, I guess, from FHE.org, which is that Shai Halevi was very excited about the idea of having a lean-based, like verified FHE, like client implementation, right? Encrypt, decrypt, keygen, and so I mean, I'm like, this is very much what is it like? Hearsay. I do not have this on the record, and this is like second information. But I think this is a notion of something that I think the community really wants, and so I don't think it's necessarily HEIR's duty to provide this, but it would be very nice to have finally like a constant time, whatever, formally verified client side, right? Because I was actually just reading the Cheddar README, and they were very obvious about the fact that no, our client side is super not secure and everything, right? And every library says this. And as far as I know, there isn't really a library that doesn't say this. So as we're starting to actually hopefully to put proof of concepts in deployment or actually look at deploying FHE solutions for real. This is an interesting like gap that's sort of left out, right? Yeah. But maybe one of the things that the HEIR community can provide there is some kind of interchain format that makes it so that we don't have to build this like 12 times for every library. Because I guess we're very good at like generating client-side helpers and things like that, right? And so maybe one of the things we can do is provide sort of like, if you have a front end that has a certain fairly standardized API, we can then like take your thing and like make it look like an OpenFHE ciphertext again. We can take your like polynomial and like, represent it, serialize it into OpenFHE, into Latigo, whatever, from a more representation. But that's like so yeah, that's getting fairly tangential to actual HEIR concerns.
Yeah, I mean, it is important though. Okay. Let me see if there's anything else on the top of my mind.
Another sort of discussion that Alex and I were having a little bit was about like HEIR's ordering of passes. I think we were talking about this specifically in order to talk a little bit about, maybe we were talking about multi-input or like batching things, and we were talking about inserting concatenation operations. But if we insert tensor concatenation operations, then write a kernel for those, then we need to know we would ideally know the parameter sizes, but we, pass that in as a user flag and determine, and then, later do parameter selection. And so there's a bit of like, chicken and egg style, like, what do we do first? Do we, and then Jeremy and I, we've also talked a little bit about like, okay, well, do we just like brute force over like some number of parameter sizes to try to like fix this problem of choosing kernels before we choose parameters? And then on top of that, we also have this discussion of like, okay, let's just defer that to like a smarter, better out of compiler system, like Rotom or something else like that. So that seems to be, and I think I kind of wanted to mention this in terms of like me adding all of this convolution support of, we're adding these convolutional support layouts, but long-term is our solution our solution is probably not going to be the way that we write these passes out in HEIR, of like assign layouts, then sweep them up through and then lower to the kernels, all while having like a fixed client specified ciphertext size.
Yeah, I think one on that note, like all the people I've been talking to who have been doing layout stuff have basically said that they define their system so that the layout that they choose uniquely determines the kernel. And I think this is because like they're only really thinking about matrix vector multiplication as the operation. But they're basically saying like, okay, like Rotom has this property that if you have a particular Rotom layout, it is uniquely defines the kernel because it enforces like a certain alignment of slots.
But the thing is like the layout choice involves a parameter selection.
The layout choice involves a parameter selection for like the number of slots, right? Yeah, and so, but like, so there's, because like, well, we have this bigger problem where we say, oh, we have the layout selection and the kernel choice, and we are selecting those two things potentially like jointly, but independently, in addition to like the choice of, but so they're saying, well, okay, if the layout includes implicitly the number of slots available, and so if you're just searching over the layout and it uniquely determines the kernel, then you can include this number of slots as part of that search. And then right, it doesn't include all of the parameters that you're selecting, right? But from the number of slots, you can get like a coarse estimate of the performance of the kernel from that. Then that's like enough. And I think I kind of agree that like the way you break the chicken and egg is that you have a coarse grained performance estimate based on the thing you're searching over and some reasonable assumptions. And like in the best case scenario, what you do is you sort of like make your performance assumptions blended over all of the options using profiling, right? You do some hard work and come up with a blended profile of things and use that for your cost model in the compiler pass at the high level. And then you have some specialization pass at the lower level that can do some more local optimizations. but yeah, I guess the other option is to have it as like use some estimator like SimFHE or HEIR as a whole as like a black box for some brute force search. Yeah, both are kind of options.
Yeah, and then I think the problem is like we don't have a way right now to just swap out our current little fixed layout prop, layout optimization, convert to ciphertext semantics. Like ideally those three things packaged together would be subbed out with something else.
Right. So like our kernels are something that can be reused, but like our current Felipe style pass is like very much hard coding to like, okay, here's the best kernel to use and try and massage all the layout conversions around that to be as not bad, as good as possible. And there's like maybe like 1 or 2 kernels to choose from for each op. And so, yeah, I think I was talking with Oscar the other day, and this is, I think, not the long-term solution that we want. We want a solver. We want something that can be smarter.
Part of me is also like, at some point, it might be worth nuking the 3 passes that, or I guess it's layout propagation, layout optimization. Convert to ciphertext semantics can exist as it is because, yeah, like you said, there are kernel lowerings that exist normally. But we might want to rewrite layout propagation, layout optimization as something that is a like, I don't know if there's like a an ILP that doesn't really do anything besides just assign and do something close to what we're doing in layout optimization. So, and not that we're really doing much in it, right? So we're
You're
really
saying just like turn the heuristic into some kind of global optimization pass to make it easier for us to work with.
Yeah, or make it easier for other people. Like I think the problem is like no one has a boilerplate template to change something with. So now we have like ROTEM as existing as like a front end that exports instead of something that exists as a like back and forth or like exists.
Well, the plan is to port ROTEM completely to HEIR.
Okay.
And then they would have ROTEM's layout notation as like something more specific than ours, and then ROTEM pass would run, and then it would export, not export, but it would just like take its output layouts and convert them to Pressburger notation, and then pass it along to convert to ciphertext semantics. So that's like the rough plan.
I guess is a question that like I just wish that we had a better baseline than layout propagation, layout optimization.
I agree. That's a good point. I mean, I guess but the problem has always been, I guess, if we are saying we fix all the kernels and we fix all the layouts for those kernels, right? Then it's just a matter of like the global solve would just be a matter of one option for each op for the kernel, and that forces a particular choice of layouts. And then there's like a layout conversion cost, and you have to like decide where to put. I feel like we could write that ILP quickly.
Yeah, I think especially if we're trying to get a baseline and sort of solve the ickiness of layout optimization and layout propagation, then we don't care too much about small minor layout conversion costs. Like, I mean, we're also
would that provide a better base? Like, is your goal to provide a better baseline or just a better programming experience?
Better programming experience, I guess.
Okay, yeah, because I feel like it would produce almost this exact same baseline. I mean, it wouldn't be greedy, right? So it would be a heuristic.
Right.
I feel like the baseline would be very similar to what we have today. Maybe you'd make it easier to like hoist things forward versus backwards.
True.
Yeah, I feel like that's definitely something we could do.
And then the other question is like, is it not worth our time? And then we just wait until ROTEM is the baseline.
Yeah, I mean, that's I think the real problem is that it's maybe not worth the time to do it.
Yeah, so I think that maybe the answer is like after 2D convolutions and CNNs, we like put up our hands and not further invest in
deprecate layout optimization pass and then try to rewrite it when we have time.
Yeah, like I don't think it's worth me. Like, I mean, implementing the layouts was like significantly very annoying to do already, that I don't think it's worth keeping that tech debt in there.
This discussion just made me realize I did find a pain point for your survey, and I'll submit that afterwards. But it's HEIR is really bad at like isolating the different parts of the pipeline at the moment, right? I've been seeing that personally with the backend. swapping thing, but I think this is partially sort of like requiring deep re-engineering, like you just discussed. Partially, it's just about making sure we have more of these like invariant checking passes that Jeremy already added for like one or two things here and there. But yeah, I think like one big way to make the user experience better is to make sure that you can do things that the like main pipeline isn't designed to do much more easily.
Right. Like, I mean, I think on pipeline engineering itself as well, like a lot of it is haphazardly just written in some order, and like canonicalizes are sprinkled through and CSEs are sprinkled through. And I think now we have better MLIR experience to know that when we require a canonicalization, that we should embed it in the pipeline of the pass itself rather than it as a pass that comes before. So I think we got better at doing that, but now that's technical debt.
Yeah, I think in some sense, like getting better at documenting how our pipelines fit together and which ones don't, and also just making them fit together more flexibly and more robustly. I think that hopefully will also make it a bit easier in the future to like maintain things, right? But I think that will be my 50 cents for the pain points thing, is that both the documentation around how the like different passes and pipelines fit together and also things like probably introducing a backend config so that we can like remove a lot of the like backend duplication that we have.
It's in progress. I already have like a draft for that. I haven't had a chance to finish.
I think part of this is just better documentation. Part of this is adding like easy, low-hanging fruit things like just better error messages, better like earlier erroring rather than in like deep conversion passes, like fail to match pattern kind of things. But I think a bit of it is like harder engineering things, like having a good generic baseline story for layout things that is way more robust, having like a backend system that doesn't quite require writing so much of the like backend specific code all the time. Like I don't know how to solve all of that necessarily, but I think like at least from the work that we've been doing at Belfort now, like those are the pain points I've really been like noticing.
Okay.
Yeah.
One of the like themes I've heard from the MLIR community, which I'm not sure everyone agrees with, but I've heard it repeated multiple times, is that like a pass is not the right granularity of thing that you should expose to someone building a compiler on top of your thing.
Yes.
It's really a pipeline. And so you should, focus your efforts on building a pipeline and have that be the thing that has invariance. And then internal to the pipeline, you can kind of do whatever you need to enforce all of that and get all your optimization in there. But it's funny because the MLIR community also has literally no infrastructure around managing pipelines, right?
Yes.
It's all around passes. So there's no documentation. There's no like table gen documentation thing for pipelines. I was thinking of adding that actually upstream and never finished my draft of that. And then there's no way to like declare or enforce invariants before and after pipelines or even after passes are run. So I was like also thinking about adding something like that. But I think that would definitely be helpful.
I mean, we can go as deep into this as we want, right? But I think there is definitely like things we can do that are more like re-engineering technical things. And then, as you said, like I think a lot of this is just MLIR pipeline things not being super well supported upstream. I mean, definitely the fact that we can't like auto-generate nice. I think you have something right now, like some script that does the pipeline thing semi-automatically, right? I don't know if that ever got fully finished, because I know you were talking about like some kind of automation around like pulling pipeline information for the docs, for example. And I think like right now, this is also still that right? Like, so I think there's I don't know if it's our job to do this, but even if we decide not to automate it, I think having a good like push on improving the documentation for the pipelines would be really cool. And also sort of, I think
we did that, right? There was one point at which I think I went through all and redocumented them, but
it's way better than. But I think also like we probably want to like prune the amount of pipelines we show to people, right? There is like, it feels like we certainly have like feature pipelines, and then we just have like pipelines that happen to be a pipeline because it's a bunch of passes that are convenient to reuse. And I think we don't really separate that from the documentation perspective right now, right? So there's definitely sort of like, here's a big pipeline that's like one of the ways to use the compiler, and then here's a tiny pipeline that we use internally somewhere, and like they're just in a big list. But yeah, I think that's, I'll fill this out for the form so you have it properly in your data set, but I can already give you a sneak preview of what my feedback will be.
That's fair. All right, cool. We are at time. I'll stop the recording. Bye, everyone.